A stone a stone A is fired vertically upwards with a speed of 40 meters per second. And 1 second later, another stone B is projected from the same point with the same velocity. The question says find the time that elapses before they collide, the height above the point of projection at which they meet. This question, you need to think very, very well because it's very tactical in order for you to be able to solve it. Now let's write down the known parameters. Let's divide it for A and for B. Now the known for A is the initial velocity, which is 40. That of B is also 40 because both stones were projected with the same velocity. Now let's look at the time. 1 second later, that is when B was projected, which means that stone B is trailing behind stone A. So if stone B is in space for time t seconds, I'm using stone B as my reference for timing, then stone A will have been in space or in air for a time of t plus 1. Stone A was fired before stone B. Stone A was projected before stone B. So stone B came later, 1 second later, after stone A must have been projected. So if, for instance, stone B is in space for 2 seconds, then stone A, which was ahead, will be in space for 2 plus 1 second, that is 3 seconds later. Okay, I'm sure that is clear. Now the acceleration of both will be negative g, and we have been told that g should be taken as 10 meters per second squared. And then that of the second stone is also negative g because we are taking the upward speed as positive. Now, by the time the two stones meet, let me just draw this, include it here. Let's say this is stone A fired vertically upward. Let's say it has got to a point such as this, and then you now, after a second, stone B is projected vertically upward. Now, by the time the two stones meet, let's say around here, the two stones meet or collide with each other, they will be at the same vertical distance above the ground. That is, both stone A and B will be at the same height above the ground at the point where they collide in space. So which means the distance raising upwards for the two stones will be the same. That is, for stone A will be the same as the distance, vertical distance raising by stone B. The two distances, vertical distances will be the same. So with this knowledge, you can proceed with the solution, writing down the equations using one of the second equation solution, S equals ut minus half gt squared, and then we use that to form two equations, one for A and the other for B. For stone A, let's call the distance raising SA as equal to 40 times the time taken for stone A would have been t plus 1 minus half times g is 10 into t plus 1 all squared. Now SA equals 40t, if you expand this bracket, plus 40 minus 5 into, that is 2 here, will give you 5, t plus 1 all squared. Now this is SA equals 40t plus 40, expanding this will give you t squared plus 2t plus 1. We expand t plus 1 all squared. So that gives you 40t plus 40 minus 5t squared minus 10t minus 5. That is expanding the bracket using minus 5. This is for stone A. Then I'll do same for stone B. The distance risen by stone B at the point where the two stones meet will be 40 times t. The time for t, for stone B rather, is t second. Okay, that is minus half times 10 times t squared which gives you 40t minus 5t squared. This is for stone B. That is the distance. And the two distances I said earlier are the same. So since both distances are the same, we are going to equate the equation A. Equate that to equation B. And then we solve for the time. That is the time at during which they collide. So I'm going to come up here to continue solving. I have here from equation A, I have 40t plus 40 minus 5t squared minus 10t minus 5 is equal to the second equation, that equation B, 40t minus 5t squared. Okay, you can see that minus 5t squared plus 5t squared gone, 40t minus 40t gone, and then what is left here is 40 minus 10t minus 5 equals 0. That gives you 35 minus 10t equals 0. So that is 35 equals 10t, and therefore t is divided by 10, 3.5 seconds. So it means that the two stones collide after 3.5. For the height above the ground at which they meet, we can use one of the equations. Let me use equation B. Equation B says SB equals 40t minus 5t squared. That is SB, what I'm looking for. The time is 4 times 3.5 minus 5 times 3.5 squared. So by the time we do the calculation using our calculator, we have 40 multiplied by 3.5. That gives 140 minus 3.5 squared times 5 gives 61.25. So that by the time I find the difference between these two, my answer will be 78.75 meters. So both stones at the point above the ground where they collide is 78.75 meters above the ground. Thank you.